Hi, I'm an old guy and I do maths. Today we're looking at how we graph 2 to the power of x plus 1 plus 1. So the first thing to recognize is that this is an exponential graph, and the general shape of exponential graphs is covered in another video of mine, and there's a link to that in the description. But just a little reminder, this is the general shape of an exponential graph. This is its most basic form. Y equals a to the power of x. So x is actually a power, it's an index. They traditionally have a long tail that in this case uses the x-axis as an asymptote. An asymptote is a value that a graph or a function approaches but never actually achieves. And then in their positive form they take off up the y-axis very, very quickly. And so when people talk about exponential growth or exponential acceleration or something like that, they're talking about something that takes off like this. Now, as I say, there's a video on the basics of this, and I thought it was about time that I did an exponential graph with a few little additives, as they say. So, how I'm going to approach this is I'm going to use the method that I use when I have to graph a function and I don't know what shape the graph of that function takes. So there'll be another link in the description to my video on dealing with the graphs of unknown functions. You'll see it there. And the method I'm going to use is quite similar to what I do there. So the first thing I'm going to do is I'm going to see what happens if I make x equals 0, which means that I'm going to be finding a y-intercept. So if x equals 0, what we have is we have 2 to the power of 0 plus 1, which is 1, plus 1. Now, 2 to the power of 1 is 2, plus 1 is 3. Now let's just say that again. If I make x equals 0, this becomes 2 to the power of 1. 2 to the power of 1 is 2, plus 1 is 3. So this point here is 0, 3. We have found our y-intercept. Now compare that to a standard one where invariably these things pass through the y-axis at 1. Now, what else do we know? Well, if we rewrite this very slightly, what we have here is a to the power of x plus 0. That 0 is an indication of our asymptote, y equals 0. Here we have an indication of our asymptote, which is at y equals 1. So what I'm going to do is I'm just going to draw in a dotted line to indicate the asymptote. I'll extend it over here, but it's actually on the left-hand side of this graph that's important. So let's put another value in just to see where this thing goes. So we make x equal 1. That gives us 2 to the power of 2. 1 plus 1 is 2, plus 1, and 2 times 2 is 4, plus 1 is 5. So we're heading in the correct direction. It's mimicking this, and if we were to put another value in, I'd say the graph would be up here somewhere. So I think it's fairly safe for me to start doing something like this. The more interesting work is done over here. So let's try x equals -1, and what we get is we get 2 to the power of 0 from that, because 1 minus 1 is 0, so that's 2 to the power of 0 plus 1. So 2 to the power of 0 is 1, 1 and 1 is 2. So we get -1, 2 here. And this thing is proceeding according to plan. Okay, so x equals -2. So that is 2 to the power of -1. 2 to the power of -1. 2 to the power of -1 is a half. A half plus 1 is equal to 1.5, or 3/2. So we are heading, I think I can comfortably state that this graph is going to look like this. And this point here, just so that I've got some room to write it, this is -2 and 1.5, or 3/2. And so what you can see is that this graph is swinging around and starting to approach the asymptote that we predicted here. And fundamentally, that's how you can go about drawing one of these things. Now that's a tiny bit laborious, so there are some rules that you can extract from this. The first and most important in the case of this function is this thing. That's going to move the graph up 1, which means that the asymptote moves from the x-axis, to y equals 1. And so if you were going to graph this without going through all of this, the two things that are important are, what is the y-intercept? That simply means putting 0 into this equation and discovering the value of the function at 0, which in this case is 3, and the location of this asymptote. And if you were asked to sketch this with the various points of interest, those would be the 2 points of interest. Anyway, that is the graph of y equals 2x plus 1 plus 1. There will be further examples in this series. I hope you found this useful. If you did, please subscribe. As I say, there are links in the description to the general form of an exponential graph, and also to the method for graphing something where you are uncertain as to what the graph looks like, which allows you to get some points which you can then connect. Okay, thanks very much for watching. See you next time. Bye.